Hi, everyone. I'm Dario, Senior Developer Evangelist at HTC, and welcome to the second in a series of our VIVE Developer Day weekly seminars. Today, I'm here to show you how to get started with the VIVE Hand Tracking SDK, which we released just over a year ago. I'll be showing you where we are now and what our roadmap will be in the near future. So basically, I'd like you to hold on to questions till the very end, and you'll be typing those into the GoToWebinar console there. So 5 years ago, while showing demos of our original generation of VIVE, many of users who were completely new to VR were so immersed that they achieved a level of presence that made a few of them place both controllers in one hand, like that. And with the bare hand, they would try to reach out and interact with the virtual objects. There was this natural inclination to use their own hands to participate in this new magical experience. Well, now, as of last year, we can do that. We can do hand tracking. And this allows this additional immersive capability to interact with objects with your bare hands. Here we're seeing your hands being shown as a robot model, but of course you can customize that to be any model. Next slide. But first, let me describe to you our developer resources, all of which are available on vive.developer.com. On this landing page, most of our SDKs are literally just a click away. Over time, we've accumulated quite a number of SDKs, so we've grouped them into 3 groups. 3 categories are VIVE Wave, and VIVE Wave platform is our standalone all-in-one platform. It's currently based on Android, of course, and we provide an SDK and a number of supporting SDKs actually for additional OEMs to implement the Wave platform. We also have Viveport, which of course is our distribution platform and store. This will include SDKs such as DLCs, in-app payments, DRM, and so forth. But what we're going to focus on today is the category called VIVE Sense. And with VIVE Sense, you have basically maps to our senses: eyes, audio, and for this particular case, we're talking about hand tracking, but along with eye tracking and even the pass-through cameras to do MR. And our VIVE input utility, which is a cross-platform toolkit for input. We consider that all under XR input. So under VIVE Sense, we have these groupings, and what we're going to focus on today is the hand tracking, of course. Our VIVE hand tracking engine, well, before that, let me just go over our use cases here. As you can see, this is an example, a project that's actually included in the SDK. This sample project basically will illustrate several things. So interactions directly with objects, remote interactions such as remote grabbing with the use of single or multi-hand gestures using ray casting as well. So you can see there he's ray casting to select an object. And if you use both hands for a combined gesture, you can do a command such as grab the object and even throw it. Before that, I'm sorry, I skipped this one. Basically, our engine supports left and right hand tracking. It supports finger level positional tracking, which consists of 21 points. That's 4 per finger and 1 at the wrist. And essentially, we have certain modes, and namely, we have these positional modes, which is 2 and 3D point modes. We have a skeleton mode, which is essentially what I just mentioned about the 21 points, and you have the ability to create custom hand models based on that skeleton mode. Here's some specs for platforms. Given those modes and that capability per platform, what's available, what's not available. As you notice, The original Vive is also supported. However, you won't get that 3D position because it's only a mono camera, that's stereo. It's the stereo cameras that give you that ability using disparity between the cameras to position 3D points. Here's some information about performance, and this is in terms of frames per second. Once again, you'll see the original Vive doesn't do 3D points. But basically, this can be improved. If you're only using one hand at a time, you'll get a better frame rate. This is based on both hands in the same frame. And here's the Android-based platforms, including standalones for reference here. And as you notice with that we can even run this on an Android phone. And here it's assuming, of course, you don't have a dual camera, so that's why you're not getting 3D point and skeleton support at this time. Getting the SDK. So once you download the package and you unzip it, this is what you see on the right here. You'll have the support for Android, for Unreal and C++, some pre-built samples. You have the full online documentation included as a download. And of course, you have the Unity package. And if you look at the latest release notes, and the latest release was released just about a month ago, you'll see that we're continually improving on performance. And we just added also another hand, the robot hand that you saw there. And that's where you can get the documentation. So these are the platforms that are supported. Once again, I'm going to be just quickly going through each of these, except for the Java one, which is for Android support. But the core C, C++ APIs, it basically makes the core of the other two. It's what's the underlying support there. But basically, we're going to go through the core APIs so far as what's the general usage, basic usage. And you're going to find that many other implementations to hand tracking will also have the similar core usages: start the engine, stop the engine, get gesture data. Here we have, when you start the gesture detection, you'll see that you'll need to specify what the backend processor is going to be, whether it's the GPU, CPU, or if you want it to automatically detect the best one to use. Also, you have the gesture modes I mentioned earlier, whether it's 2D point, 3D point, or the skeleton mode. And of course, you can always stop the gesture engine. This is a blocking call at this point in time until the pipeline actually stops. You won't return. And in some cases, in our implementation, for example, in VIVE, it may be taken care of by the OS. Get gesture result. Here's where you can actually specify which hand you want to get a result for the gesture you requested, or if it's the points, the 21 points that you want from a positional point of view. So it's generally you use these enums and these structs. And again, this is C and C++ with the same across the platforms. Here's the Unity and Unreal usage. We're going to, in Unity, you're going to attach a gesture provider script to your camera and then specify what kind of backend, what mode. It's just those two settings. And likewise, in Unreal, you're going to be adding the VIVE hand tracking component to your scene. And again, you have similar options there. The next API to check is detection, because when you start up the engine, it could take a little while. For example, in Android, you may have to grant camera permission. Also, while things settle for a deep learning pipeline to start off. So generally, you do want to check to see if the status is not started, starting, running, or if you have an error. And it's very similar again with the Unreal in Blueprints. And here's where you actually get the results for either left hand or right hand. And one thing that's interesting is you can actually check to see if it's been updated in this frame. And again, this is to save on processing, so you can just detect it. Well, if nothing changes this frame, they don't process anything. Here's another use case. Let's see if I can get that video started. There we go. In this case, it's a very basic drawing, or you can actually make this sculpting or anything that requires this manual, it's more natural interaction. Here, you can also use gestures to toggle between different modes of drawing. So you want to start erasing, or you want to change brushes and so forth. Again, this is a lot of what you could do with controllers. You can do here. What I also wanted to mention earlier is that, hand tracking is not really meant to necessarily replace controllers. There's still use cases where controllers can be better, or vice versa. So it's just going to open up opportunities for new types of experiences and not just one-to-one replacement. Here's another example. This is called VIVE paper. In this example, this is actually on Viveport, so you can try it out. We're using gestures, hand gestures, and it doesn't have to be gesture recognition. You can do similar to what you do with controllers. You can detect if your hand is moving based on the 2 or 3D point tracking, whether it's moving across your field of view to indicate turning pages. In this example here, you see some QR codes. It's because on the Vive Pro, you can actually detect QR codes using the front-facing cameras and actually change the content. So you can actually combine SDKs. Here, I'm going to show you the different models we support. Actually, we introduced these models in the sample code provided. In the current version, we introduced the robot hand. In the previous version, we had these hands that included forearms. I customized these hands just to be hands without the forearms. And what I want to talk about right now is how to customize these hands. So from the perspective of developers, you would import your new model as an FBX file into your scene. And then you would add, in the case of Unity, you would add a model renderer script component to each of the hand objects. And then you would make sure it's set to all the joints for that model. And again, we have these example FBX models that you can use, you can review and see for reference how it is that we mapped it using this model renderer script. Here's a long list. I'm not going to actually read through each one, but this is basically a checklist of what needs to be done on the side of modeling for 3D artists. So the custom model must contain a mesh, a skin mesh renderer. That's pretty much the first two bullets here are the main two requirements. The other ones are just details, how you're going to rotate, how you're going to set default state of the hand. And I also recommend for certain packages that you include some animations just so you can export it correctly. Once they have that FBX, you should be able to use it. And again, reference our other existing FBX files for reference. I'm going to go through now a quick step-by-step on using how to just get started with Unity. I mentioned before the gesture provider. So what you want to do is add this to your main camera. And again, you have these options, what backend to use and what mode you want to use. Getting a question now. I'm going to actually take care of the questions at the very end. Let me just walk through this guide, at least walk through this guide, and we'll handle questions when we talk about, right after I give these tips of what to do, what to look for in general. So number one, you add that to the camera. Number two, you add the model render script to each of the corresponding hand model objects like I mentioned. Here you see in the inspector view the script. You're going to specify if it's left hand or right hand. You're going to specify if it's a robot hand because the way we do the mappings is slightly different than robot than regular hand. Of course, you're going to have all the 21 nodes mapped directly to the part of the model that corresponds to each one of these. You'll also see that we specify the mesh under hand, so that robot_r is the mesh, again, from the FBX. And then at the very bottom, we have collider type. Collider type is just indicating whether you want it to just trigger an action or if you want it to actually generate colliders for each of the fingers, each of the joints. So it'll do that work for you. Now, you don't have to use it. You can actually manually create these capsule colliders for each one of the points, but it's just a convenience that this script actually does that for you. Number 3, we're going to handle gesture recognition. So hand state checker right here in the middle. Let's start with the top. Hand display switch script in this particular example simply switches from the skeleton mode to showing the model when you do a specific gesture. In this case, it would be a thumbs up gesture that makes you toggle between those two. Here, hand state checker, there's 2 main conditions, prepare and trigger. So that in general, this is in case you need 2 conditions like aim, shoot, you know, and a lot of similar things like aim and grab, like you saw in that remote grabbing example. So you want to do is use the thumbs up like gesture on both hands to trigger that. And in this case, there's only a prepare condition. Now the reset conditions in case you lose tracking in the left hand, right hand, if you want to reset the state, because again, there's 2 states here if you need those 2 states. And here, let's see if we can get this video running. We have an example of the collider or trigger types. Trigger on the left, collider on the right. Let me go back. See if we can get this going. Maybe a little delay here. But this is another view of that same project, that sample demo that comes with the actual SDK. You saw the remote grabbing before, and there's some instructions, as you've seen at the far in the back, exactly what actions you can do. In this case, I was trying to show you collisions with the, there you go. So there's the switching to the model. Here, I'm using the colliders that's in each finger to actually push that big cube. Now I'm doing an OK gesture to actually indicate I want to grab this, lift it, and throw it, and so forth. So that's that use case. This other use case shows you how I'm having difficulty picking up this little small box because I'm basically trying to just use the 2 colliders on each finger. And this is one of the things I'm going to talk about a little bit. You can't just rely on just the colliders. Sometimes you need to be smart about it and do what you were doing with controllers as far as trying to help make it look realistic without actually being realistic, like a friendly versus native way of approaching this problem. And basically, and just to finish that point, you want to combine it with animations, or you want to combine it with changing the colliders based on what kind of actions you're trying to do. In this example, it's going to recognize the point gesture, and it's going to cast a ray as if you would with a controller on this remote menu. So again, with menus, you can actually have them really close, so you can have them coming out of the other hand and press on physical buttons using the colliders, or you can use ray casting to select buttons. Let's see if I can get this running. There we go. And you can do selections that way, and you can actually do maybe a pointer, a click would be maybe just moving your hand as if you were pressing remotely. All right, so let's talk about some of these, so what I've learned with using hand tracking so far. As I mentioned, don't assume 100% accuracy just to avoid additional work. As you noticed, I went through 3 of those tips, and you're up and running. Do some more work. Use some third-party libraries that are smart about hand physics to make it look realistic without having to avoid doing that work. Do add animations, like I mentioned, or custom colliders. You can actually probably change colliders in real time, or I guess I call them animated colliders. And again, use gesture recognition in combination. So you notice if you have the right gesture to indicate you're going to pick something up, then you can actually have the object actually help you pick that up. And make sure to use natural interactions. And basically, you can use the combination. Like I say, you can try falling back to position-based gestures, as you do with controllers, and compute the gesture movement yourself. Also, when I say natural interactions, I'll get to that in a little bit. But basically, just make sure you don't need instructions. You want to reuse your controller code for as much as possible. A lot of us have been using hand models for when we're using controllers. Try to reuse that, and the best way to approach this is by abstracting as much as possible. This is a general rule when working with cross-platform tools. If you get tied into one, it's hard to break out of it. Try to abstract your code so that you can easily switch between these, and hopefully we'll have a SDK that can handle both controllers and hand tracking. Consider the fallback solutions. For example, if your controllers are running out of battery, you can switch to hand tracking within the game, within play. So there's all these things you need to start thinking of, not just make it a hand tracking mode only or a controller mode only. Let's try to combine that and try to reuse the code between those two as much as possible. Play with scale and position, make it magical. Surprise with the unexpected. There's a lot of interesting experiments happening right now in hand tracking in general. That's a lot of videos online. People are sharing a lot of their ideas. I think you noticed it earlier. I showed this mirror effect. That's again inspired by one of the developers out there, one from Swiss. His name is Dennis. He just look up hand physics lab, and you'll see a lot of good examples that can inspire you. I'm going to talk a little about roadmap first, and then we'll try to wrap it up. We're always doing improvements on the tracking and of course on the UX itself. We're going to add a new gesture, pinch support. That's the thumb and index finger only. We're not going to go through each combination of thumb and ring finger and index, and pinky and so forth. Again, try to, like I was getting to mention earlier, try to make it natural. That's a natural gesture. I think if you add more complex gestures, you're gonna have to teach the user what those do. So go with natural things, point, okay, and things that's universal. We're going to allow you to add custom gestures to the recognition engine. It's work in progress. Again, this roadmap is for several releases ahead. We may have one or more of these in the next update. And by the way, the next update will be next month. So we try to do this to iterate as frequently as possible. We are currently working on supporting the XR faceplate. That's the high resolution cameras that you can add to the Cosmos for XR experiences. Please stay tuned to another webinar specifically on that. But for now, what I'd like to say is that we are making sure that this will work as well with that. Hopefully, because it's higher definition cameras, we'll get higher definition tracking. We're going to finally add an official hand model. Those two models I mentioned before, they were part of sample code, but we are working hard on adding an official hand model that we can use across platforms. And lastly, this other new feature that I don't think we've announced before. This is going to support develop index. So, it's not like we haven't supported it before, as far as tracking, as far as use of the front-facing cameras. But those cameras are a little different. They have different camera characteristics, which is crucial for making sure the tracking is correct. So we'll be adding support for that. We just need some work. We need to do some more deep learning on that set of cameras. And for the most part, this is really exciting time for that. Here are the main links. I'm going to experiment and try something now. See if we can do this live. Okay, I'm just going to go through those 3 steps using Unity. As we kind of promised a hands-on coding session. Just want to double check that this is being seen okay. Basically, I'm going to go through those very simple 3 steps. How to get started. Let's say you started a new project in Unity and you want to just want some verification that we're seeing this. You want to basically start with a new scene. So what do? After you install the VIVE hand tracking package, what you want to do is make sure, like we mentioned, the first step was in your main camera, make sure you drag and drop that gesture provider into your main camera. So once you have that there, you'll see you have your gesture provider and you can do your selections here. You can always just go with the defaults. Next, you want to be able to drag and drop your left hand model and your right hand model. And really, that's the very basics. Okay, so I'm going to go back to our last slide here. So these links, the download, the documentation, the forum, especially the forum, I highly recommend there because we have our engineers tracking that and they'll answer questions. You'll get the latest info there. Again, just remember to go developer.vive.com and you can find these links there. And with that, I am going to take some questions. Please use the question panel to type in the question. It's on the right part of your screen. Question from Conrad Kuntz: does this work on non-HTC hardware? Well, I mentioned our first announcement here of supporting the VIVE Index. I believe we should be able to port to other platforms. Again, the only challenges are, of course, access to the cameras and their characteristics in order to make sure it aligns correctly and to basically test it with our deep learning models. Question from Marios Bikos: is the camera not enabled in Steam VR? I tested this earlier and it was all set up, ready to go. And I think it's a combination of the GoToWebinar being on at the same time, it having to switch audio and all that. So it's why it's the most difficult live. Question from Christian Lopez: I might have misheard during one of those slides. What did you say regarding use of simultaneous control and hand tracking? Oh, what I was saying is that you can actually gracefully fall back one way or one direction or the other. You can, if you decide to turn off your controllers, you can detect that at runtime, or if the controllers just die because the batteries die, you can actually switch to hand tracking, which is very convenient. Again, depending on the use case. So a lot, maybe first-person shooters, it just doesn't make sense to use hand tracking. But for anything that's menu-driven, for anything that's like a video player, I've used it in video players. Okay, 2-part question from Stephen Zhu. What are some use cases for hand tracking? Is the hand tracking SDK reliable, ready for enterprise applications? I illustrated some of the videos there with some use cases. Simulation, learning, training, those are the really valuable ones. Anything that requires using your hands for a specific learning task, especially when the controllers can get in the way, makes a very good use case. And obviously for enterprise, doing training is very important. Question from Robert Gilliam: do the different cameras, Valve Index, XR Faceplate, VIVE Pro, VIVE Gen 1, have an impact on tracking quality? It should not. It's because the tracking quality is going to be mainly dependent on various factors like CPU, GPU, the lighting. Of course. I failed to mention that, but basically lighting affects this. This is all camera-based. There's no infrared here. So those are more important factors than the actual cameras themselves. Obviously, like I mentioned, you still need the characteristics. For example, on the index, they're much farther, wider apart. So to get the right stereo, you just need to know all the characteristics. And the original VIVE only has one camera, so you're not going to really get much of depth. Question from Yihan Lissov. Could it be used with Oculus Quest or Oculus Rift? Is it currently better than Quest hand tracking? This is still early access. We're still iterating very quickly on it. The more we feed it to our deep learning model, the better. It's getting better with every release. I think we're all moving very quickly ahead to better tracking. I mentioned some of the variables that may affect it. As far as working on the Oculus, this is a very core, simple SDK. What I'm seeing is actually the opposite. Can third-party libraries like MRTK, it's just a mixed reality toolkit that is just showing a lot of progress using hand tracking. Can that be used with this? I don't see why not. You can integrate some of the larger toolkits to use any of these hand tracking SDKs for Oculus or for Magic Leap or for us. In fact, Unity already is providing their new XR architecture already provides for subsystems, and one is hand tracking. So you can actually write drivers so that eventually, in the long run, we'd only use one SDK to support all these devices. Question from Christian Lopez. So to follow up, is it possible to use left hand controller and right hand tracking, for example? Yes, I don't see why not. You have to specify which, obviously, and make it very clear to the user. I think it could be confusing for users unless you're very explicit as to how this is working and what is left and right and so forth. Question from Gernot Zimmerman. Does the SDK work with external data, like data gloves? Interesting. I suppose this is, again, modeled for the 21-point tracking, for the finger tracking. I suppose if you want to change the lower level to feed the correct data, like I showed you with the C and C++ APIs, you could probably do it, but you have to, yeah, we don't have a program or plan for that for third-party hardware, but it's something that we can certainly consider. Question from Robert Gilliam. How does the library handle edge cases, such as gloves or a user with a missing finger impact tracking? Interesting. It's a very good question. If you're missing a finger, what happens? I would believe that you would have that. If your model still has the finger showing, then it would just be like a limp finger that's not really tracking. So that wouldn't be good to see. I suppose we can add an option such that if you're missing movement from a specific finger, not to show it, but that'd be tricky to actually implement. That's something that we can look into though. Question from Ashwin. You had mentioned that hand tracking SDK supported on Android phones. Do you have an example? Do you know if AR co-integration is supported? Very good question. Again, this SDK is very basic. As you can see, it's just start, stop, get gestures, and so forth. I don't see why you can try to integrate it with ARCore yourself, but we're not providing that work right now at this moment. That could change. But again, the reason why it's easy to port it to Android phones is because we're supporting our focus, which is Android-based, and it was just a matter of how we packaged it so it's easier to port it. Let's see, but I think I may have missed an earlier question. Just looking at these questions. It was a duplicate. Gernot had asked about Data Glove. It's very similar to what I was just mentioning for personalized VR interaction. I don't see why you couldn't use the skeleton mode with your data. We provide all the code in our scripts, of course, how it matches to the actual model joints. So I don't see why not. You can probably drive the same models, and this is something I would want to see being used actually to share these models and the way we're mapping it to see if we can support more platforms, not just hardware, but to support the controllers as well with the same models. And unless there's any other additional questions, I'd like to thank everyone for joining in. Sorry for a few of the technical difficulties, but I'm really excited about this webinar series. We have quite a number of really interesting ones coming up. Next week, I believe, is David Sapienza with VIVE Sync. And please stay tuned and check out our listing of all the seminars. And thanks so much for asking the questions and joining us today. Oh, one more announcement. Some of these sample experiments I've been doing, I'm going to be posting on GitHub. So you can look for that on, just look for VIVE or VIVE software on GitHub. So you can actually start experimenting with me. Otherwise, just please grab the SDK and check us out on the forums if you have any questions.